All right, so that correlation value of 0.917, how would you interpret that? What does that mean? Strong positive correlation. General form would be what? Linear. R value, the stronger it is, the more like a line it is. So there's a fairly strong, remember we always want to soften our descriptions with, fairly or moderately or whatnot. I would call this a fairly strong positive linear relationship, and then you need to include context here. It's a fairly strong positive linear relationship between city fuel economy and highway fuel economy. Pulled right off of the XY axis. If you change your units, R stays the same. Changing units does not affect the strength of this relationship at all. Rolls-Royce gets 14.4 city MPG and 25.5 highway MPG. So that guy's right down here in the corner. That falls in this linear pattern. It's away from the rest of our data, but because it's following that overall linear pattern, it's going to strengthen our R value. So it's going to bring it closer to 1 if we included that. If we have an unusual value that is not following the pattern, it's going to weaken R. If it's falling in this linear pattern, it will strengthen R. Do you guys have any questions for me about correlation and R value there? Yes, sir.
For number 2, I said the same thing that it wouldn't be affected, but I said the scale will remain the same.
So technically our scale here is going to change, but the proportional, like I would find another way of wording that, because if you're changing units, your scale technically is changing there. But the relationship, if you change the scale on your X and Y axis, relationally it's not going to change. Does that make sense?
Yeah.
Okay. Basically, I would just be renumbering the axes here, but those dots would all stay in the exact same positions. So right at the end of class on Friday, we talked about how correlation is not the same thing as cause. Two things can be very closely related to each other. We can notice this relationship. It can even have an incredibly strong relationship. That doesn't necessarily mean that one factor is causing the other factor, or that one variable is causing the other. I wanted to show you guys a couple. I talked about these on Friday, but I wanted to show you a couple graphs of some outrageous correlations and why, no matter how strong or weak it is, we cannot determine cause from correlation alone. You guys okay if I bring up that other example? Okay, if you need to snap a quick picture, I'll leave it here. I can bring it back to this here in just a moment, but I wanted to show you guys this. I put it on our page for today so that you can see them as well. These spurious correlations, I find these absolutely hilarious, but this is why we cannot say that one is causing the other. We're measuring two very, very different things here. Look how closely those two graphs match, though. Disturbingly similar. Obviously, the U.S. spending on space science and technology has absolutely nothing to do with the way someone becomes unalive. Number of people who drowned by falling into a pool, and films that Nicolas Cage appeared in. I'm not a particular fan of his acting, but I've never taken that as a reason to jump into a pool and not be able to swim. Cheese consumption, a number of people who became tangled in their bed sheets and passed away. These graphs are really disturbingly similar. Graphs get used a lot in media representations of results found from studies. but they can be very misleading when presented to the public without some context behind it. And if all you're showing is that these two things are very closely related, a lot of times media will want to infer a cause and effect relationship here. There is no cause and effect relationship, I wouldn't think, between the divorce rate in Maine and the consumption of margarine. So there's lots of funny ones on here, the age of Miss America and deaths by hot vapors and hot objects. Not a lot the same here. Okay. You guys are welcome to investigate some of those. These are always quite funny to go through, especially when anybody tries to say, well, the graph showed, like, but what's the graph really showing? The graph is showing a relationship. It's not showing cause and effect. All right. I want to play a bit of a game with you guys. Find an open spot on your piece of paper. We're going to play a couple rounds of this. We're going to play a correlation guessing game to get better with our R values. You guys are welcome to come in here and practice with this also. There is a link to it on our daily page. So this is going to put up 25 data points, and I want you to try to guess what that R value is, what that correlation value is. So just a spare spot somewhere on an empty corner or in a margin. You'll want to write down your guess. All right, so here's our first one. What do you think the R value, the correlation coefficient, would be here? Write down your best guess, and then I will show you what the answer is. Like I said, we're going to do this a couple times. We know it has to be in between -1 and +1, so you should have a decimal value. Decide whether you think it's a positive correlation or a negative correlation. Remember, the weaker it is, the closer it is to 0. The stronger it is, the closer it is to either -1 or +1. You guys ready to see what the actual R value is? 0.197. Very weak correlation. Let's try another one. What is your guess for the correlation value, the R value? Jot your guess down. Yes, ma'am.
How do you know if it's negative or positive?
Good question. Negative or positive? So as you're reading this graph, from left to right, if it appears that as you move from left to right, those points have a general downward trend, similar to a negative slope, it's going to be a negative correlation. If moving from left to right, those dots appear to have a general upward trend, they're going higher on the graph as you move left to right, that would be a positive correlation. Great question. You guys ready to check this one? Just ballpark, positive or negative?
Negative.
Negative, strong or weak? Strong, so probably very, very close to -1. Exactly -1 on this one. Our R value is exactly -1. I can grab a straight edge and draw right through all those points. All right, let's do a new one. Does everybody have a guess? Positive or negative?
Negative.
Negative. Not as strong as the last one, as weak as the first one? No. I see a general linear pattern here. -0.8. Is that higher than you were expecting? That's a much stronger relationship than you might have been expecting. It doesn't look exactly like a line, but when I look at it, I see a linear pattern to it. All right, let's do 2 or 3 more of these. What about this guy? That's my face too, Joan. Am I going to ask you guys to give me a precise R value on the exam? No, not without data. But it's really good to get into the habit of being able to look at a scatter plot and to say, okay, where do I think my R value would approximately be? Is it going to be strong? Is it going to be weak? Is it going to be positive? Is it going to be negative? What do strong relationships look like as scatter plots if they're not perfectly correlated, not a perfect one or a perfect negative one? What do they look like if they're moderate? Do you guys think this one is strong, moderate, or weak? This one looks pretty weak. Positive or negative? Negative, but not very, like negative 0.037. If I see an R value like this, I know that a linear model isn't going to help me make accurate predictions. I might not have a better model, but I know at least that my predictions aren't going to be super accurate based on this R value. Take a guess. Positive or negative? Negative. Question before we check our R value. This guy up here, is that strengthening or weakening our R value? Weakening. Why? It's away from everything else and it's not falling in this general pattern. I could have a point right down here that would be far away from everybody else. But this value, if I had one down here, would that strengthen it or weaken it? That would strengthen it because that would like fall in this linear pattern here. Let's check this R value. Negative 0.32. Negative 0.32. Let's try another one together as a group. I would encourage you guys to get in and click on this and just practice a couple on your own. Because again, having a visual understanding of, okay, this is about what a 0.8 looks like. This is about what a 0.3 looks like. Will be very helpful. Try this guy. You guys ready to see the R values? Positive or negative? Positive. Strong, moderate, or weak? Probably moderate. If I had to choose like which side of moderate, I'd say it's moderately strong versus moderately weak. I think it's more on the strong side. Is this guy right here strengthening or weakening our R value? Strengthening. 0.7. 0.7. So yeah, I'd call this guy either strong or moderately strong. All right. Like I said, I encourage you guys to continue practicing with this. You have access to this link, and you can just keep trying. You can type your guesses in here and check them against these values. All right. Before we move on to the next thing in your packet, I want to take a moment, because we didn't have a chance to do this before. I want to debrief our first two tests. So first, I want to show you guys kind of where we are. We're in a statistics class, so I have a statistical analysis of our tests. So here was our Chapter 1 test results. And this is after the curve was applied. There was a curve on both the Chapter 1 and Chapter 2 tests. There will continue to be curves on the test first semester. So the mean on our first test was about a 78. It was 77.9. The median was a 78. When the mean and the median are close together like that, even without this picture, what do you know about the distribution? It's fairly symmetrical, and that matches what I'm seeing here. Most of our class fell right in here. We had a couple people on either side here. Maximum was 92, minimum was a 61, so nobody failed the first test, which was awesome. I've got my dot plot and my box and whisker plot. I'm going to pass back the Chapter 1 test so you guys can see those. You're welcome to ask me any questions about that, and then we'll kind of look at the same kind of breakdown on chapter 2. All right? All right, if you're still looking at your chapter 1 test, that's totally fine. I'm going to go ahead and bring up the statistics about the chapter 2 test. This one was a little rougher. Our mean was a little lower, not a ton. The mean this time was about a 75. Our median was almost exactly the same. Median was actually a little bit higher this time, 78.5. Maximum was a 94, minimum was a 50.5. So on this one, you can see from the graph, the box plot, or from the histogram, we have a little bit of a left skew going on. So that's why our mean is lower than our overall median. I'm going to pass these back. If you're done looking at your chapter 1 test, I'll go ahead and pick those up at the same time if I haven't already collected those from you.
Do you need our quizzes back?
What'd you say?
Do you need the quizzes back?
I do not need the quizzes back. I just need the tests back. You guys are welcome to hang on to the quizzes. Are you done looking at chapter 1? Okay, no worries. So now, are you done looking at chapter 1? Are you done looking at chapter 1? Wait, sorry. My apologies. I was looking at your name and I handed you the one right behind it. So as a reminder, as far as grades and stuff go, if you didn't do as well as you would have liked to on either of these first 2 tests, please, please, please make a plan to stay after school and study with me. I'm after school Tuesdays and Wednesdays. If Tuesday, Wednesday doesn't work for you, I can't ever do Mondays. They schedule meetings for me on Mondays all the time. So I can't do Mondays. Tuesday and Wednesday I'm here every week. If a Thursday or a Friday works better for you, talk to me. A lot of times that's when I'll schedule doctor's appointments for myself and my kids, but if you need to meet with me and I don't have an appointment, I'm absolutely willing to stay. Tuesday, Wednesday, to stay and study with me, you do not need to set an appointment with me first. It's nice if you let me know that you're planning on staying, but you don't have to schedule an appointment with me. You can just kind of drop in. Those were drop-in office hours, all right? We are not going to get through everything that we're starting right now, but I do want to go ahead and get started on this next piece in your packet. So we're going to be on page 7. So back to Barbie and the rubber bands. The data from one of our groups is here in this table. And if you will notice, they forgot to collect data for 5 rubber bands. And I actually noticed as we were doing this around the room that there was one group that they're like, oh shoot, we forgot to get this one. So this is definitely believable that you left one out. I want you guys to use your calculators and make a scatter plot for this. Do you guys remember how to use the graphing calculators to make a scatter plot? Stat and edit. You're going to put the information in those 2 lists, list 1 and list 2. You should have that little calculator cheat sheet if you need to remember how to do that. Remember to clear out a list. You're going to highlight the name of the list, and then you'd hit clear and enter.
Can I get the
Yes. Where did I put that at? As soon as I locate it, yes, I will get it for you. leave that one out. Don't put 5 in that X list for right now. My apologies, yes. Leave that one out or else it will give you a dimension mismatch. So do not put 5 rubber bands in. So we're going to enter all of this data, but we're going to leave 5 rubber bands and the corresponding distance out.
It's my five.
I need help.
You need help?
How do you?
All right, so go up to the name of the list. Go up until you're highlighting where it says L2. There you go. Now hit clear and enter. And then you can enter those distance values. Don't put a value in for 5.
Yeah, that's why I tried skipping it, but it put it in there anyway.
As far as skipping a value,
Yeah.
you don't want to leave a skipped value. It'll give you an error. It'll give you a dimension mismatch. So just pretend like that was not on the table at all.
So take out the 5?
Yes.
Oh.
Yep. So when you guys are entering list 1, you're not going to put the 5 in there on list 1. You're going to leave this one out. So 0, 1, 2, 3, 4, 6, and 7.
Oh.
Pull up my calculator too. Stat, edit. Go to list 2. I don't want to see that. There we go. So 25, 32, 41, 49. 55, 69, and 78. Don't forget to hit enter at the end. You should have a matched list, and 5 is totally missing here. How do I make a scatter plot now?
Second Y.
Second y equals. Make sure it's on. Scatter plot is which one of these? First one. So mine was not set to scatter plot. We were doing scatter plots last week, so yours might already be set to scatter plot. Mine was on something else because I used my calculator over the weekend. And then to graph this, I'm going to push zoom and 9 so that it sets my window properly. Looks a lot like what? Looks a lot like a line. Sketch this off to the side on your page. And then we're going to find the equation of the regression line, which we've technically already seen where this is. We just didn't write it down. We didn't talk about it. So to get my regression equation, I'm going to go to stat again. Do you guys remember where we went for the R value? It's very, very similar to that. I'm going to push stat. I'm going to go over to calc. Option number 4, that looks like slope-intercept form, right? So statisticians actually want to switch it where the y-intercept is first. This is a lower down one. It's going to look very similar to this, but it's going to say a plus bx. I'm going to scroll down, and I'll tell you why here in just a minute, why we're doing this one. On mine, it's option number 8. It's like inverted slope-intercept form. I'm going to choose option 8, hit enter. To actually get it to give me my regression equation, what do I still need to do? Hit enter again. It tells me the value for A, and it tells me the value for B. Yours should also give you the R value. I reset my calculator over the weekend, so I didn't turn my diagnostic back on. So my equation here if I was going to write this regression equation down, y, and then we put this little hat over the top of it, equals A comes first. This is my y-intercept. I'm going to take that out to about 2 decimal places. So 25.33. Is my B value positive or negative? Positive. So I'm going to put a plus 7.46x. You guys okay with how we got this one? Would I get the same equation doing the option number 4? Yes. Here's the reason that we prefer doing y-intercept first and then the slope in my variable. Let me pull this back up again here. I'm going to write this guy down. Oh, that's too much. 5.33. Plus 7.46x. When we write regression equations in statistics, we usually never, ever, ever use x and y. We always want to be including context. What is our y variable representing here? Distance traveled. So I would write my regression equation as distance hat. It almost looks like a roof over the top of this. So distance hat equals 25.33 plus 7.46. What did x mean? Number of rubber bands. So inside parentheses here, I'm going to put rubber bands. It's much more convenient to have that x at the end when I'm inserting a word there than if I try to do that in the middle of my equation. One of the other reasons why statisticians prefer to write it with the y-intercept first and then the slope is that sometimes in real-world situations, oftentimes, there's more than one explanatory variable for a response variable, and we can refine our models by adding those other explanatory variables. That is beyond the scope of AP statistics. We're not going to get into doing that refining, but that's why we'll put it at the end, because that y-intercept is going to stay constant. All right, we're going to pick it up here tomorrow, and we're going to use this regression equation then to make some predictions about Barbie.